Example 2. Waiting times for airport security. Given the uniform distribution illustrated in the figure below here, find the probability that a randomly selected passenger has a waiting time of at least 2 minutes. So we can see that the height here is 0.2, and then we can see that the width is 5, which is waiting time in minutes, and the area is equal to 1. Now, what we want to do is we want to find the waiting times of at least 2, or the probability of x being greater than equal to 2 minutes. So let's take a look over here. Down here, the shaded area represents the waiting times of at least 2 because it is greater than or equal to 2. So we're shading everything in there. Now, because the total area under the density curve is equal to 1, there is a correspondence between area and probability. We can easily find the desired probability by using areas. What we want to find is the probability of wait times of at least 2 minutes, or the probability of x which is greater than or equal to 2. So what do we know? We know that the height, which is equal to 1 over the range, which is equal to 1 over 5, which is equal to 0.2. And how do we find the width of the shaded area? Well, you can see the shaded area goes from 2 to 5. So in order to find the width, we need to take 5 and subtract 2, and then we get 3. So the area is equal to the probability of x being greater than or equal to 2 is equal to the height times the width. Well, we see that the height is 0.2 and the width is 3. So 0.2 times 3 is going to give us 0.6, which is what we get over here. So therefore, this shaded area represents the probability of 0.6. And therefore, we would say the following. We would say that the probability of randomly selecting a passenger with a waiting time of at least 2, meaning in this shaded area minutes, is 0.6.